Okay, what I want to do in this video is give you a bit of an orientation into CVP waveform recognition and monitoring. Just to give you a little overview of this page, what I have in front of you. Here's a basic EKG tracing and a CVP that corresponds to that, a CVP waveform. On the right, you'll notice a breakdown of the different parts of a CVP waveform. I'm not that interested in you memorizing this, but it's just here for your reference. And then below is an EKG, an A-line waveform, and then a CVP waveform. So we can refer back to these as we go forward. So let's look at a standard CVP wave. It's got sort of three distinct parts that correspond to a beat of the heart. You'll notice the P wave, which as you recall is electrical atrial contraction here. So correspondingly on the CVP, you'll notice that the pressure goes up. Now remember, this pressure is a measurement where the superior and inferior vena cava dump into the right atrium. So remember, this is not atrial pressures. These are venous pressures just before the right atrium. So these pressures are going to go up in the A wave as the atria contract. You'll see a decrease in pressure and then a small bump here, which is the C wave. This corresponds actually to the ventricles starting to contract. You'll notice the QRS complex here. So the ventricles are starting to go into systole. They're starting to contract. This little bump actually represents the bulge back of the tricuspid valve, the valve that separates the atria and the ventricles on the right side. So as the ventricles contract, you get a little bulge in the tricuspid, and hence the CVP. The ventricles push out all of their blood, pressures drop, and they drop again until essentially a pulse of blood goes all the way through the body, the arteries and back through the venous system, and then the second rise is actually the filling of the right atria. As those atria fill, the tricuspid is closed, remember, so you're going to start to get an increase in pressure to the V wave. Now as those atria start to passively dump their blood contents into the ventricles, you get this Y wave, or this Y descent. So that's as the atria passively empty. So your CVP drops back to 0, and then you're back to your baseline, which is the beginning of your A wave. And remember, your A wave is your atria contracting, and you can see the corresponding relationship between the P wave and the upslope of that A wave. So this is a basic CVP waveform. In reality, if you look down here at the bottom, this is more what a CVP waveform might look like on a real patient. It's a little more slurred and not as clear as the example above. I hope that's helped with your understanding of CVP waveforms. Next will be arterial waveforms, which we see here.